Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, welcome to Happy Path Programming. We have a fun one today. So we have with us Nathan Sobo. Did I say that right?
Yeah.
Yeah. And you live in Boulder, but you are here in Crested Butte, Colorado. So we get to have you in person, which is super fun. We don't get many of those. So great to have you. Quick story to kick us off. So back in May, I was going to LambdaConf, I think it was in May, down in Estes Park. And on the way there, I was listening to Richard Feldman's podcast. And so I was listening to the episode with you. And then I get to LambdaConf and you're there and I get to meet you. And then I just I'm like the little puppy following you around all weekend because you're so awesome. So great to have you here on our podcast. So let's kick it off with who are you, what you do, and tell us about Zed and all that. Give us the pitch on that part.
So yeah, I'm Nathan Sobo. What I do for most of my career has been I've been on this pursuit of building the ultimate code editor. I remember the year after I graduated from college, I was working for a professor, and he had me build this first-order logic model of English grammar. And as part of that, I was reading this site. I don't know if it's still around. I haven't. It was called Lambda the Ultimate. It was a programming language blog.
Yeah, still.
And I learned about packrat parsing on that site. And there was this packrat parsing framework for Java. I think it was called RATS with like a exclamation point. Anyway, I built a packrat parser to parse his like first order logic language, and then proceeded to try to make it work, and it didn't go that well. But the one part of that project that did go well was the parsing part, and I got into my head. I was using Emacs at the time, and then I was also playing with Eclipse, and then I think Rails had come out right around then, and I saw DHH using TextMate. So I played with all these different editors, and I'm like, I really want something kind of that has the vibe of like TextMate, this friendly, lightweight, fun tool. The power of Eclipse without the slowness that I experienced at the time. And then like the tinkerability of Emacs. And I was like, and wouldn't it be cool if it were like all based on a packrat parser, and there'd be syntax trees, always available in the editor for any scripts that you wrote. So I got it in my head. I think that was 2006 that I wanted to build this editor. And then I worked on it for a while. I learned Cocoa. It was going to be a Mac app. So I learned Cocoa back before like iOS had even come out. So it was a pretty fringe subject at the time, and didn't get too far. Moved up to San Francisco, worked as a consultant at Pivotal Labs for a while, and did a bunch of pair programming, which added a new idea into my budding dream of building this editor, which was for it to be collaborative and enable this style of programming that at that point in time required like you to come into an office, plug in two keyboards, and two mice, and it was a very particular setup. But I loved that way of working. It was really like feeding my social soul.
Sure.
And so, yeah, in the background, I was starting to work on the editor, like nights and weekends. I would like come into the Pivotal offices on the weekend to use their computers and like work on the editor, which at the time was like, I decided to start with the parsing engine. And didn't really ever flower into an editor, but what I did do is present that parsing framework was called Treetop, which was like popular in the Ruby community for a hot second,
As like an AST parser.
Yeah, exactly. There was like a testing framework called Cucumber that was written on top of my parsing framework. I never used it actually. But anyway, I presented it at RubyConf in 2007, and the GitHub guys were there. And so a few years later, I had I tried this other project. I won't get into that, but I had worked on it for like about a year and realized I still couldn't let go of the editor dream. And a friend of mine was like, you should talk to the... Oh, go ahead.
It was just eating away at you. Like, you really want to solve this problem.
Yeah, well, I think the problem with the other project is it was sort of... I made it more technically complex than it needed to be because that's just how I am. And
none of us have ever done that.
Yeah, exactly. Nerd snipe myself to death building like my own ORM framework and all this other things that were not relevant to the problem. And at the end of that, I think I decided I need to actually work on the editor because the editor actually is an incredibly technically hard problem. Like that's sort of a big part of what makes building an editor hard is it's just the technical difficulty of that. And that would be perfect for me. So
this is about the experience of clicking somewhere, writing code, and tab completion. Like it's like the interaction model is what you were like, okay, at some point I got to get to that part because that's kind of how the developers are going to experience
and also building all of your own stuff, even though you didn't need it then. Eventually, when you're working on this and you started using Rust, you realized, oh, I'm going to have to build a transportable UI framework.
Oh yeah, I mean I can fast forward to that.
Oh no, don't skip too far because the Atom Electron piece is also interesting.
Yeah. So my plan and how I got in, I drove here from Boulder, right? So not too far, but how I got to Colorado was Pivotal had an office in Boulder. My plan was to just live somewhere remote and less expensive than San Francisco and kind of do 6 months a year of consulting and then 6 months a year grinding on an open source code editor. And I had everything set up to leave town. And a friend of mine was like, you should talk to GitHub and see if they want to build the editor. And so I tracked them down at the million user party, like the party celebrating their millionth user at Public Works. I tracked Chris down and was like, we should build an editor, a social code editor. You guys like social coding, but we're only doing kind of the async piece. What if we could also do the sync piece? And it was a couple days later, we got coffee and they told me, oh, we've been working on an editor called Atomicity at the time, which was later shortened to Atom. And they'd been working on it for like a few weeks, I think. And we sort of, I got in there with all of my strong opinions and we started over from where they had it.
And that was, what was that being written in?
That was being written in CoffeeScript at the time, which doesn't even exist anymore, I don't think. But you can kind of picture that was the end of 2011. And so they were a Ruby shop and CoffeeScript was kind of big with the Ruby community. And JavaScript was pretty hard to use at that point, honestly. Like the ECMAScript 5 changes hadn't come out yet. So it was not a crazy choice to choose CoffeeScript, even though...
because it was a standardized way of doing things, and you didn't have to worry about all the weird underlines.
Well, how did Electron fit into that piece of the story?
So Corey Johnson, who was working on it with Chris at the time, he had basically wired, like at that point, WebKit was available to like Objective-C programs as a standalone, as a library. And you could write like Objective-C functions that would bridge into the JavaScript code, and the JavaScript could call out and invoke Objective-C. And so he had hacked in like some basic I/O primitives and stuff, but they're all synchronous. So it was like you load a file and it would block. But it worked, and it enabled, I think it was Ace, which was like a web-based editor. And so it was Ace and these like hacks to get out to Objective-C. And so the first thing I was worried about is like, we can't do all this synchronously. And then I was thinking, I really want access to like the NPM ecosystem. And so we sort of worked on the editor that first year and a half-ish. But then a lot of the time I was also spending like trying to figure out how can we get like access to NPM and V8 I knew we should probably use V8 if we wanted access to the Node ecosystem because Node was based on V8. So I was playing with this thing called the Chromium Embedded Framework. And then later on I was like poking around in forums, like asking questions, trying to figure out like, I was in way over my head, honestly, with the the C++ Chromium code base, just trying to figure out how can I do this. And I think this guy named Cheng Zhao, ZC Benz is his GitHub handle, saw me asking questions and realized I was from GitHub and reached out from somewhere in China, I don't even remember, and said, I can help you build this. I love GitHub. I can help you build this. So I remember getting on I think it was a Skype call with him. We barely understood each other. It was like, but I just sort of stumbled through describing this framework, and then I eventually wrote it down of just like, it needs to have Node. I basically just described Electron, and we hired him as a contractor. I don't even know how they managed to get him paid. And eventually that, after like months of it crashing and us sending him stack traces or core dumps or whatever, we finally got to a point where like we could, it was called Atom Shell. So Atom Shell, we eventually, when we decided to open source that, I think it was Chris came up with the idea of, Atom Shell, it's like the Electron.
Yeah.
Like that's the orbital shell or whatever. And so that turned into Electron. So
that became the way to build the whole UI, the Atom editor on top of Electron so that you could distribute it out to all the platforms and not have to like think about that underpinnings. It's just let the Chrome team, figure out a lot of the
UI primitives, right? Which came with a serious cost, which was just like, I don't know. I mean, what's amazing is like the VS Code guys came around. We launched Atom and it like just took off like a rocket. Yeah. And I think Microsoft...
I built plugins for Atom.
Thank you.
Yeah.
Nice, yeah. And we, of course,
gave you... that crazy CoffeeScript UI framework.
Oh, God, I know. Yeah, and there were some questionable choices that we made all across the board, right? Yeah. I think we were really young and...
You just didn't know what you didn't know.
Yeah. But yeah, then Microsoft at some point... kind of had a meeting with us and they showed us like the early versions of VS Code, which was like they had taken, I think, Visual Studio Online, which they had a whole team working on in Switzerland, Eric Gamma, and they'd built Eclipse, and Microsoft had hired them. I don't know all the details, so this is just take it with a grain of salt, my understanding.
Yeah. But they were doing something similar basically in parallel. Right. And also built on Electron?
Well, they saw it was all web-based initially.
Okay. Yeah.
I think they saw Atom like taking off and they saw Electron and they're like, "Oh, cool. Let's do Atom."
Good idea.
But I think they approached it with sort of a more mature team, a more mature mindset. Like our idea with Atom was to build the modern Emacs. So it was like, "Oh yeah, we'll initialize your extension on the main thread at startup." Well, oops. Like add 4 or 5 extensions for people that don't care that much about performance and like say goodbye to startup time, and then like running an event handler like on the main path of typing characters on the main thread. Yeah. Whereas
let's get slow.
Yeah. So their approach, I think, was they forced all the extensions to run out of process, which was a much better choice.
But then you have to RPC to like talk to the syntax tree or whatever,
right? Right. I mean, it's not without its trade-offs as well, and I don't think it's the best long-term, and I don't think it's how we're going to approach it in Zed, but it was much more sane than like running arbitrary untrusted code on the main thread. So that, I don't know, they eventually sort of, obviously, as history has shown, like relegated Atom to the dustbin of history, and yet it was still like just a fabulous environment for me to learn and do it wrong repeatedly in order to learn how to do it right. And so, it was... Yeah, how are we doing on time?
Great.
This was okay.
Love it. Okay. Make sure it's still recording.
So anyway, like it took us a long time. I mean, extensibility was like an early priority. Meta or Facebook at the time ended up having a team that was probably like 5 times the size of the Atom team, building all Facebook's internal developer tooling. It was called Nuclide on top of Atom.
Wow.
And I don't know, there was so by the time, I think it was not until 2017, I think, that we finally got around to being like, okay, let's do this collaboration piece. Because that was when I'd, years and years earlier, I'd pitched Chris
on the
on
social
doing.
coding.
Yeah, and we had still
Collaboration
hadn't gotten
first,
to it.
yeah.
Right. And so it was at that point that it was in, I think, spring of 2017. I had no idea how we were going to do it. And we were looking at operational transformation. And then years earlier, I'd played with CRDTs. But at that point, it was just really memory inefficient, the approach that I had taken of giving every single character in the buffer like a unique, globally ordered ID. And especially in JavaScript, I mean, maybe in a systems programming language where you could really optimize things, that would have been somewhat sane, but like it was just not gonna work. And then I ended up abandoning it anyway to do other more important things at the time.
Yeah.
But this time around, we sort of dove in the literature and, after playing with OT for a while, kind of ended up being like
OT?
operational transformation,
Okay.
which is sort of the approach that Google Wave took. Operational transformation, the mental model there is like, the central problem of like implementing collaborative editing is sort of, I insert a character at offset 10, and then I relay the fact that I did that, but meanwhile, you insert a character at offset 5. And so now
10 and 5 don't align anymore.
Exactly. Now offset 10 no longer represents the same logical location in the buffer. And so the solution of operational transformation, as it is described in the name, is, well, I take that operation, insert character at offset 10, and transform it so that it makes sense in the new world. But as we got into like implementing undo stacks properly, or I don't even remember, there were a lot of papers. None of them it just seemed like that whole field had not converged on like a single best way of doing it.
And how does CRDT solve that problem?
So CRDTs frame things a little bit different, where you're sort of, rather than thinking about the operations as things that need to be kind of mutated in and of themselves so that they make sense to apply on a remote copy, it sort of reframes the problem and says, how do we structure this data in a fundamental way such that the operations are inherently commutative? And so what that tends to involve is just adding a lot more metadata to the underlying data structure that you're editing, so that what you're sort of showing one version of the data to the user, but underneath what the user is seeing as just plain text, there's actually like a lot of metadata writing along. And so that ends up, and yeah, so I can get into the details of, I mean, maybe we could just talk about that now.
Since we're there, let's do it. So let me check one thing. So on CRDTs, there's many different kind of implementation, like different ways you can do CRDTs. I think generally they use algebras to give you guarantees. And so commutativity is one, it can be implemented maybe in multiple CRDTs, but that's kind of one algebraic property that you're trying to achieve through this data structure of a CRDT. Did I get it all right?
I think so. I mean,
Did you create your own CRDTs?
We did, yeah.
Okay.
And we did it by like reading these papers, trying to understand what the hell they were talking about. I don't know. My problem with academic papers a lot of time is there's a lot of formalisms. There's a lot of like what feels like kind of things left to the imagination or not technically specified or whatever. But we managed to sort of form our own picture of what would make sense and implement it. And what we ended up arriving at is sort of for every block of text. So imagine we start with a shared buffer, and that will give the initial text of the buffer like a unique ID that we can both reference. And then every participant in the collaboration will be handed out an initial like replica ID. And so that means that each participant, by virtue of their replica ID being unique, can also have a local incrementing counter. and they can just mint unique IDs because they all have this unique prefix, and they can just mint these unique IDs.
You don't have to use a global coordinator.
Right, exactly. And I think like going forward, I almost want to just start experimenting with using UUIDs. I mean, it's 128 bits, but it's just like, it's like a vector or whatever, right? It's not that much memory on a modern machine.
Yeah.
But it's not how things are implemented now. We actually do global coordination to like hand out that initial set of IDs. But then imagine like you give every chunk of text, so that could be if I'm typing individual characters, then each character is going to get a unique ID. Or maybe I paste a big chunk of text. That big chunk of text is going to get a unique ID.
So both the individual characters and the chunk of text get in
any change
UID.
Yeah, like if I insert, let's say I paste, 1,000 characters, that entire 1,000 character chunk will be tracked as a single insertion, and it will have one unique insertion ID,
but
which is
not all the
individual characters.
Okay, that makes sense.
Because
so you're doing it where you started saying, oh, I guess we have to look at each character, but then at some point you go, no, we need to look at it on a chunk size, right? That's just, and that was a practicality thing, or was that just something that, I don't know, somehow it made sense?
Yeah, I mean, I think we probably pulled it out of a paper. I don't even remember at the time. But what felt really clear is like giving each individual character a unique ID was pretty expensive because you start with this initial buffer state, and what we realized, probably with the help of some of these papers, is as long as each inserted piece of text is treated immutably, you can use the unique ID plus an offset starting at 0 into the buffer, and you can always find a location that is unique, and so as long as you never delete anything. But then the question is, well, how do you do that? How do you never delete anything? And the answer is kind of dumb, which is just when you want to delete something, what you actually want to do is hide it. And so what the buffer looks like under the hood is actually that it's ever growing, monotonically increasing. That's one theoretical word that I use a lot when we're talking about CRDTs, is just this idea of monotonicity, that it always needs to be growing. And as long as it's always growing, you never throw anything away, you should always be able to kind of craft things such that you can identify, even if it's inside of some deleted text, you could still identify that text and then identify kind of where it is in this global document. So you kind of build up the document as this like accreting, causal, directed acyclic graph of like, or it's just kind of a tree that's fanning out, right? Yeah. Where you start with the base text, then I say, I want to insert this new, maybe start with this base text, and then I say, I want to paste in 100 characters at, 0, like ID 0.0, right?
Not
just
a
like the
position,
base text.
It's a
global ID, and then an offset into that, right?
Okay.
And so I can find an offset into this piece of text. Now I have a new piece of text that is part of the document, and you can imagine sort of incrementally subdividing the document by inserting all these new pieces of text, but they're all just like, I'm gesturing in a way that will not come through on the podcast, but this sort of tree of text inserted in some place with a stable location, and then that new text now has a stable location, and so you can always kind of accrete more and more data.
And what this enables is the collaboration piece, but then also you use it for being able to like undo or something, like the history for undo is
right. Because so this maintains or allows immutability throughout. Is there ever any kind of, I don't know, for lack of a better word, sort of garbage collection? Do you ever get to a point where you go, okay, let's this out?
We haven't needed it yet. We haven't implemented it yet.
Oh, okay.
But I think in theory you definitely could garbage collect. That would obviously take a moment of global coordination to sort of agree, okay,
right,
back to this point in time, we're all going to pretend that it's maybe one coherent block of text or whatever, and freeze the world at that point.
We have a pretty efficient data structure because there's no replication of of data that's not a change, right?
Correct.
So,
But I mean, obviously, over time, like it is going to build up. It's just like again, it has not been. Yeah, I mean, I'm kind of.
I mean,
Git
it
has
could be
the,
premature. I'm jumping in. Premature optimization would probably
Right.
be the.
Well,
if
Git has a
you don't
Git
need it,
GC,
you don't
but
need
I
it.
never have to GC my Git repos because they're never too big to
Well,
get.
except didn't we do that once where you like rebased it or something like that? I don't remember what the phrase is.
I had to purge our history for our
Yeah.
book,
Right.
because I didn't want the history to be publicly available.
We were
Oh.
embarrassed.
No, we didn't want to give away the book for free on the
Oh,
website.
right.
Initially, when we started working on the book,
It was open.
It was open, and
Nice.
then once we got to near published, we pulled it out, and
That makes sense.
I didn't want to get history there, so
Okay.
it wasn't
I get it.
wasn't a GC. It was just to rewrite the history down to
Okay.
Yeah, I mean, like the way we handle undos, for example, is just like every insertion is associated with a counter.
Mm-hmm.
And if the counter is 0 or even, that insertion is visible. And if the counter is odd, it's been undone.
Huh.
And so when you decide if a piece of text is deleted, you first have to check. You can have one or more like deletion markers associated with it. And then you check the undone or redone counter for those deletions. Were the deletions undone? And then also, was the insertion itself undone? So there's this weird sort of like Boolean
Mm-hmm.
calculation of like, is this text actually visible in the current version of the document or not? But it's always like there under the surface. And we have not yet garbage collected it, which we will, I think, need to deal with when we get into building the future. But I feel like I should. So we built that CRDT, the initial CRDT that built this thing for Atom called Teletype. And
So this was done still in the Atom days. This is all
Yeah.
all pre-Zed. So
Yeah. And I think it was from maybe April, I think, we started digging into the research, having no idea how we would implement it. And we shipped a working extension for Atom that let you do collaborative editing, I think in October.
that's pretty
We
quick.
busted our asses to get that out the door that fast. And at the end of that entire process, I was like, wow, we are now actually pretty good engineers in a way that, obviously you never know it all, but I felt like I'd crossed some sort of milestone. I'd like, and it was at that moment where I'm like, shit, we need to start over. I just was frustrated.
You learned all the things that you knew you would want to fix if you could do it again.
Yeah, I just felt like Atom didn't represent the engineers we were in that moment. It represented
Your
the
journey.
exactly all the mistakes that we needed to make to be like, hoisted naked in front of Hacker News so they could throw rotten vegetables at us, so we could feel the pain of having done it wrong and
Yeah.
work harder and get.
I think you only really get good at something when you do it over and over again.
Yeah.
And each time you go, oh yeah, that's not right. Let's start from the beginning. I've had that experience, and it's like, I don't know, it's very gratifying because the understanding is deep. So once you started using, so you built the CRDTs in Rust.
Well,
No,
we did it.
Oh,
Oh,
no,
this was before we got to Rust.
Yeah.
But you now know how to build a CRDT.
I now know how to build a CRDT, and I now know how to build a proper performant algorithm. Like the concept I told you could be very slow if you're going to walk through the tree incrementally. I think we used
You had some experience building efficient tree handling.
exactly how to index things properly. We actually had
Hashing or something.
every chunk was actually a member of 2 different splay trees simultaneously. There was some crazy stuff going on where I'm like, I'm really proud of this. Now, we wouldn't do it that way in Rust because they had parent pointers, etc. But like at the time, I don't know. I just felt like I'd
Come up with a data structure and an architecture that could be the right thing for collaborative.
I'd finally done something right.
And did you use the CRDTs for a while?
Yeah, we did.
So this was an Atom
Teletype. Yeah,
Teletype.
Okay.
And so it added collaboration into Atom.
right. Although it was not as good as it needed to be. We handled the collaborative editing part great, but there were a lot of other pieces of that problem that weren't solved.
And so what? And at what point did you say, we can't do this anymore. We gotta go back. And like, you knew about Rust, or you,
Yeah.
okay.
I've been following Rust. I don't even think it was 1.0 yet, or maybe it had just gone 1.0. I don't remember the exact.
Long ago.
Yeah. I've been following it because we've been using a little bit of C++ out of frustration with web tech, and you can write V8 extensions in C++. So we had dropped Adam's buffer out to C++.
So there are some optimizations that you had
which
to make.
We're sort of like,
you were using C++ for those, and
yeah, whether that was a good choice or not was hard to say. And
what would your other choices might be? What else?
yeah,
stay in JavaScript and and use better. I mean, because I think, I don't know, Visual Studio Code, did they have anything written in C++? Maybe a few things like Oniguruma or something. They're like, it's a regex engine that they call into.
Oh, yeah, that's right.
But like, you know, was the buffer not being implemented in C++ like really the problem? Or were there, but I don't know, like, I'd used it enough to have just this sense of being like frustrated by being in this single-threaded scripting language that was constantly pausing. At times I didn't control to collect garbage, and I couldn't control how memory was allocated. And I'd finally, by playing with the C++ enough, come to understand, you know, what an affine memory model might get you in terms of performance. And just, I wanted more control, and I felt trapped by, and also just the browser, like, it's slow, and you look at the timeline and you just see this like box that's totally inscrutable of just like something that the browser's doing.
right. Yeah.
And I have no idea what that is. Why is this layout so slow? Or trying to implement like IME, like Japanese and CJK character input and stuff, and having to do these like unholy hacks to sort of position an input box next to where the cursor was. I just always felt like I was fighting the underlying platform to like get the control that I needed to do the thing, and then just running up against a performance wall. So it was after Teletype. It was like 2017, fall of 2017, or like November, I think. And I remember writing in my journal and just coming to the realization, like, I don't want to do this anymore. Like, and it was hard because I was sort of the spiritual leader of Adam at that point, and like, it was really difficult to just let go of the inertia and the expectations of all these people around me, that I was just going to keep championing this direction.
Yeah.
And I didn't believe in it anymore.
Forever in my life that I've created,
right?
Or can I make a choice to put it down and go somewhere else?
Right.
Where in this time frame is the Microsoft acquisition? Because then you've got GitHub with Atom and Microsoft with VS Code, and you know.
Yeah, I think were probably contemplating it at that point. So it
hadn't happened yet.
It hadn't happened yet. I think there was a bit of a leadership vacuum at GitHub at the time. Like, it was just it was a weird time. Like, so 2018 rolled around, and I remember the team had a summit in Boulder, the Atom team, and I remember the slide presentation I put together, and I said, we have to do Atom 2.0. We have to start over. And everyone's just like, what are you talking about? Like, okay, man, whatever.
But in that you identified, here's all the foundational things that are holding us back from the experience that you really want to deliver.
If we can't learn and do better, what is the point?
Kind of, yeah. I mean, and so they basically, I think I'd been around GitHub for long enough at that point, and there was a little bit of a lack of, like, Atom was an afterthought anyway in the big GitHub story, that there was a little leeway for me to like indulge this obsession. And so we started this project called X-Ray. I didn't want to call it Atom 2.0 because that just felt like a terrible PR move in case this didn't work out or whatever. So I thought, it's X-Ray. It's like what happens when you split the atom. Like, it's this.
Right.
Nice.
And it was experimental. I don't know. So we started it, and I started writing these posts each week just to make sure that, like, anybody in product that wanted to know what we were doing and up to would like see it, but they were all public in this public repo. And what it started as like an internal report picked up like a pretty big readership actually, and people were really excited about it.
Just within GitHub.
Within the broader community.
Oh, okay. So it's
like
public.
Yeah, I think some of these posts maybe ended up on Hacker News, or I don't remember how people found them, but there was like started to like take on a life of its own. If that makes sense. Just
all around X-ray and the progress on X-ray.
Yeah, exactly. But then I think I had my second daughter, and then right before that, the Microsoft acquisition was announced. And by the time I got back from leave, I don't know, it was sort of, the writing was on the wall, like, we're
not doing X-ray.
We're not doing X-ray, and furthermore, like, we're not doing Atom either, you know?
Yeah,
like,
not our thing.
They didn't announce it for a long time, but yeah, it was just,
you kind of tell that they were putting together a plan to not have to have two competing code editors.
Yeah, and they set me down and, had a nice conversation about the future. And so...
We don't see you.
Yeah, it was really hard. It was like, I never in my life had more money because of the acquisition, and I was, fairly early.
Okay.
And yet I had no idea where I would go next. Like, I just had felt like, cool, you sort of filled my bank account and completely rug pulled my
purpose
dreams.
of your life.
Your life purpose.
And yeah, I hung around for a while working on webhooks, which was like a whole other saga. Actually, my manager... he's
find some way to be useful, and you're like webhooks.
Yeah, well, somebody sort of saved me. Yeah, I mean, we don't even get into too many of the details, but the manager of the Atom team was not a huge fan of me.
That's always fun. Huh?
Yeah, anyway, I'll probably cut this out, but yeah.
But VS Code was written mostly in TypeScript. Is that how?
Correct?
Okay.
Yeah,
it moved from, at least my understanding was that they started with JavaScript, and they got to the point where they couldn't move forward anymore because the code base was manageable, and so they created TypeScript as
I think Anders had been creating TypeScript for a while. I think he was just trying to solve that problem.
I mean, brilliant move, because trying to build a code editor in an untyped scripting language is like trying to build a cathedral out of popsicle sticks. It's just like, I'm amazed we got as far as we did with it, but it was not fun. It was just not good.
So then Zed, or was there something between leaving GitHub and...
For a while I tried to let it go.
You mean the editor?
Who cares about those dreams? I'll just work on webhooks.
Well, I was working on webhooks, and then I was, I tried to learn. I was like, maybe I want to work on Bitcoin, because I was excited about the vision of sound money. Oh, you don't like that, but
the vision. Sure. the world that it created is like,
but I just didn't see anywhere that I really added value or plugged in on that project anyway. I'm like, it's pretty much done. It's just not, so then I don't know. I just, for a little while, tried to think of something else that I cared about doing, but everything I cared about doing always circled back to writing software in an editor that I didn't love. Knowing that I felt like I could do something better. And so at some point I was just like, fuck, it's fine. Okay. I have to do this.
And so when you decided that, how long before you said, we need funding or whatever?
Well, I mean, I didn't even know that. It was 2019 when we sort of scrapped what we've been doing in X-Ray and started over again, this time completely on our own time.
2.0.
Yeah. I think we might have called it Zed. I mean, it didn't take me that long to come up with the name Zed. Sometime in 2019, it was me and Antonio just in our free time working on it.
And what were you building that with? What language were you building that?
Rust.
That was so
So
you had
that's
moved.
X-ray was also Rust.
Oh,
Really
I didn't realize that.
bad Rust.
Uh-huh.
And then
because you didn't understand
we were learning, yeah,
Sure.
and it was just a brutal learning curve. But we finally. This is getting really long on the historical
I
thing,
love
but
it.
okay.
Oh, yeah,
Okay. We finally. I felt like Antonio was really key in coming up with some of the key ideas behind
Antonio who?
Antonio Scandura. He's my
Okay.
co-founder.
Okay.
He was I think he had left, or he had been forced out of GitHub because they didn't want to employ him in Italy or something after the acquisition. There were corporate reasons why. Yeah, it was hard, but he was working for another company at the time, and
just on the side.
But you had known him for a while in GitHub. Okay.
Yeah, and we were friends.
Okay, good.
So we just kept pushing it forward, and then 2020 rolled around, and we all know what happened in 2020.
I've forgotten.
Yeah, but yeah. So I don't know. Like Zed, I was still working for GitHub. I'm doing a good job for them. Like they gave me great reviews, but like Zed was like my
passion
place to go where I had total control, right? You can imagine rewriting webhooks from a bunch of single-threaded Ruby processes, each eating 700 megs of RAM blocked on outbound I/O.
Imagine that.
Rewriting that in Go, which is like, yeah.
Some fulfillment to that, but
it was a slow, very painstaking process because we had customers.
You can't break things.
Exactly. It was just the opposite of what I love about software development, if that makes sense, of just like very uninteresting problem that's somehow still very hard to get right because of all these historical edge cases, etc. And it's like clearing a minefield.
Yeah.
That's what that felt like. And so Zed was a place to go for me at night where I was in charge. It was 100% interesting and fascinating. You know,
you're learning Rust and still seeing this dream of all the things that you'd learned and being able to do it all better.
Right. It was the place I went for sanity. And so, I grinded on that all through 2020. And then in the fall of 2020, I got a cold email from the founder of Warp, the terminal, Warp. It's like a fancy terminal emulator that, anyway. So he's like, do you want to work on a developer tool? My now ex-wife was terrified at the idea of me starting my own company. But I'm like, okay, cool. Here's a company I can join. I can almost work on an editor. It's a terminal. I don't know. I somehow talked myself into it. And then, I don't know. So I joined then, or I agreed to join them. And then shortly after that, my ex-wife asked me for a divorce. We were a 2020 divorce, casualty
of COVID.
or whatever, and it's okay. But but then I went ahead and still joined them, which I think it was a mistake, and I licensed them the bones of Zed that I've been working on because I'm like, if we're gonna build a dev tool, I'm not effing doing another Electron tool. Like, let's do it in Rust. This is the right way to do it. And so I worked there for like 3 months. And then
you give them ownership of what you'd worked on. Yeah.
I know. It's like a parable or some sort of, I've learned a lot since then about like...
we've all made mistakes.
Yeah. And it's open source now anyway, although it's GPL, but whatever. Like, it's fine. It was, I think, maybe a step I needed to take. But it was like, I was sort of 3 months into that job, 2 months into like being on my own after being married for a long time, and just like sort of looking at my life and just being like, you know what? If I don't like do this thing I actually want to freaking do, then what am I doing with my life right now? And I had some savings. And so my plan was I'm just gonna start working on this. Wow. And I have no idea where this is gonna go. And for at least, I'm like, maybe we split them up, etc., the proceeds of the divorce, but like, I'm like, okay, if in 2 years I hit 0, I can go get a job or whatever I need to do. And
she had some runway, and Antonio
he couldn't. I was going to be just me,
Yeah.
just me sort of working. But then I quit my job, and it was, I think, a couple days later, my friend, who, you know, helps to have good friends, but my friend was part of this world that I knew very little about, right? He had a venture fund in Boulder, Brett.
Okay.
Has venture fund V1.
Brett
Jackson.
Oh, okay. No, that's not the one I'm thinking of.
And he's like, hey, I want to invest. Here's a check. Like, I'm in for $250K. And
So that was like an angel investment? Yeah.
or he had a fund, but, you know, that would have been like a seed investment.
Right. Okay.
And I don't know. I was like, oh, I never really thought that I would be able to get investment for this idea at this moment.
Huh.
Mm-hmm.
I figured I'd toil in the wilderness and, like, at some point figure some path forward out. And so I was like, oh, well, maybe I'll see who else wants to invest. And it was like 2 weeks, whirlwind, talking to all these people. You know, I got some introductions. Rob Mee, who founded Pivotal, is a mentor of mine. I emailed him. He referred me to Lee Edwards at Root Ventures. They ended up doing the seed round.
Wow.
And within, like, from sort of no plan at all, 2 weeks later, I had $2.5 million.
Wow.
And I could
And
bring in Max and Antonio.
nice.
Yeah.
And you're like, now the vision, you see like a path to your vision.
Mm-hmm.
Yeah, I mean, step one is, like, we need to even be able to use Zed to work. So that was 2021. And then it was just a year of the three of us grinding. We brought in Nate, our designer, over that summer to make sure that, like, whatever we came up with looked good. And just about a year later exactly, we started writing code on Zed in Zed for the first time.
Oh, that's cool.
And then, but I don't know.
Like
Now
for,
it's like
for a lot of compilers, it's like the moment you can compile with your own compiler.
Exactly.
So for you, is writing a code editor is the moment you could actually be working on Zed in Zed.
Yeah. I mean, I remember the first time I, like, started editing text in this, and I'm like, holy shit, this is amazing. Because it's so fast. And I did not know. I just, you know, I was like, we are going to make this as fast as we possibly can. But until I actually had it and felt it under my fingers, like, I didn't even really know what I had.
Yeah.
Yeah,
So,
because
yeah.
we're used to these massive things that have all these layers of interpretation.
Reapply CSS styles and reflow the DOM on every keystroke or whatever you're doing inside of Electron.
Mm-hmm.
Or, you know, you can be inside of a terminal emulator, which is a lot faster, but comes with its own set of trade-offs.
Mm-hmm.
So what are so going into Zed, what were the key things that you're like, here's what we need to do better this time?
Right. Well, I knew that I wanted to bake collaboration in at the core of the product.
Which seems like something you would have to do it right. You'd have to do it from the beginning.
That's how I feel.
Yeah. Because otherwise you're just, everything that you are trying to work on would have to, it seems like you'd have to do it.
Yeah.
And even then, I think, I don't know, I still have a sparkle in my eye to reboot some of what we built yet again and kind of, like that house down the street in Crested Butte, sort of lift some of the pieces of Zed off the ground and put them on an even new foundation. I mean, a big part of our ethos is not being afraid to take aggressive, deep cuts, revisit
There was
stuff.
a word for this you said on Twitter just in the last week.
Oh yeah, shreds.
Shreds.
Yeah, I don't even remember where that word came from, but now it's, like, become part of our, like, company vocabulary or something. The idea of shredding something.
Yeah.
And I think,
Putting it through the shredder.
but it really means, like, you know, being willing to take a big bite and kind of let the compiler and like absorb a lot of blood to get something right. And, you know, you need to think carefully before doing something like that, but not being afraid to do it is, to me, really important. Otherwise, you just end up in all these local maxima and you're stuck and you're kind of, I don't know, you can take things really far incrementally. You know, XP taught us all just how far you can take things, but I still believe that sometimes you get to a point with something where you realize, like, the DNA of that thing just can't take you where you want to go. What you've learned in the process of getting it to that point now needs to be kind of precipitated out into a new version of
Otherwise,
it.
you're going to be beholden to the sunk cost fallacy forever.
Right,
If you can't do that, yeah.
right.
So okay, so collaboration. You're like, this has to be
Right.
in from the beginning,
Foundation.
and
And
so
then
so
performance.
CRDTs. So
Oh,
we're
yeah.
working on collaboration. So that was where CRDTs in your experience there then led you to the architecture that would enable that kind of in the core.
Right. Yeah. Like every buffer in Z fundamentally is a CRDT. And it was really important because in Teletype, we sort of built the CRDT, then it kind of bolted on and observed the buffer. And it was sort of this double bookkeeping. It just never felt quite right.
But the core of the editing experience is the CRDT now.
Exactly. Right. And then also making sure that we architected it in such a way that it could be multi-threading friendly. So obviously the choice of Rust being a big part of that. But just because you've chosen Rust, also using persistent data structures. So not only is every buffer a CRDT, every buffer is a persistent copy on write B tree that makes it really easy to kind of O1 clone an arc and take it to a background thread, do work in the background. Then it being a CRDT is really great because I talked about those like
Immutable
stable
data.
anchor reference points.
Yep.
Well, now you can kind of go to the background, do work, take it back to the foreground, and make sense of what the hell you've done because it's anchored to locations. And even if there have been edits in the meantime, you can.
So there's this relationship between the architecture of the CRDT and the concurrency that you also want, so that you can drive the performant. Never lock in you're always going to be able to move your cursor around or get
exactly.
Yeah.
Like we're parsing on a background thread. We're soft wrapping on a background thread.
Yeah. You can imagine, like you're saying, if you hadn't had thought, okay, we need good concurrency for good performance, we need a CRDT for the data structure and the collaboration. If you tried to put those two things together after the fact, like it's not going to go well, right?
Yeah. And performance has just been at the core of everything we do. You mentioned premature optimization. I guess there's a difference between premature optimization and sort of worrying about performance later.
Mm-hmm.
Like performance is something that I think we need to decide if you care about performance to care about it from day one, and just make sure that things are architected and keep checking back on your assumptions. So just that doesn't mean like optimizing stuff that doesn't matter, but it does mean, I think, paying attention and prioritizing it from the beginning.
I think an example of that is if you don't have performance as a stated goal, then you may not have built something that could be run concurrently,
right?
And then you're not going to be able to actually optimize for that performance later.
Right, exactly. So it needs to be to the best of your ability, like baked in to the core architecture. So those were like really the first two big foundations: collaborative, really freaking fast, and then with everything we do, I want it to be elegantly designed, and that's about sort of being user friendly, but not like assaulting the user with affordances and icons, and like trying to walk that balance between sort of friendly but sleek. That's a continual struggle.
Yeah.
But then the next big piece that is like an exciting new frontier for us and a place we're actively learning is just the rise of language models and AI, and the fact that like we now have a technology, doesn't always work perfectly, but like to me it absolutely blows my mind that I can type a chunk of natural language and have it spit out a program, oftentimes a correct one, or one that's close, and I can tweak it. And so we're digging in there. I mean, one place the CRDTs are amazing there is we're building this feature right now called live diffs, where when the LLM proposes like a set of we have this feature called multi-buffers, first of all, which is basically like excerpts from files all over the code base that are all brought together in one editor, and you can kind of move your cursor from the top of one file to the bottom of another, all inside of one editor with these little windows into different parts of files from all over the place. Even do like a multi-cursor edit that would span multiple files potentially.
That's cool.
But it's amazing for this live diff feature we're building, which is like the LLM will propose this set of changes, and it's sort of pulled up in a multi-buffer where you see all the proposed changes with excerpts across all different spots in your code base. But because what you're looking at is actually it's like a live branch. It's sort of each buffer that has been changed. What's actually been changed is like a branch of that buffer
via the CRDT.
Via the CRDT, and if the upstream buffer gets edited in the meantime, we can merge that into the branch in real time, like with no conflicts.
With no conflicts.
Yeah.
But also you can show the diffs.
Like the diff will adapt itself,
Okay.
even as the base buffer on which the diff is applied. I mean, obviously you could edit right in the spot where something is, but for edits that are kind of not directly conflicting, there's just this really, and there are probably ways you could hack this experience together, again, bolting it on top, but like for us, it's just like really straightforward to create this little branch buffer and just automatically send operations from the origin to it, and then we want to merge the changes back in. That becomes really easy.
It doesn't matter if the change is coming from some remote developer working on a file you're viewing, or if it comes from the LLM, or who cares, right?
Yeah, right.
It's all coming through the same mechanism.
It's just some sort of contribution.
Yeah.
So do you see, you're building this foundation really, I don't know, foundationally. And but I'm starting to say, it seems like you could build things on top of this that you're not even imagining.
What other domains could you go
right
into?
Because you're putting these really solid foundational pieces in. It seems like maybe there's a are you thinking in these terms? Are you going
I mean, often I'm just thinking about like the next 3 months.
Sure.
I'm just like
This is kind of where Eclipse went. Is Eclipse was originally just an IDE, but then they're like, no, this is the foundation of so many pieces of software. And so there was some branding of Eclipse where IBM or whoever was being like, okay, we could build business applications on it. Anyway, so it's a similar concept too.
Yeah.
So that is what you're saying.
Well, the UI, so the UI framework is called GPUI because it's the UI framework optimized for the GPU.
About that.
And it's Apache 2 licensed right now, although we haven't really bent over backwards to make it. It's not like Rails right now, right? We're not promoting as its own thing. It's like in our repo. But eventually, I do think it'd be great when we have a little more bandwidth to spin it out and let other people build fast desktop apps that are cross-platform with the same tech.
Yeah.
Maybe there's more Rust UI frameworks that are out there now than there were when we started on this thing, but this one's gotten a lot of love and has a major application being built on top of it and a lot of resources dumped into it.
And we'll eventually have a Windows.
Yes. There's actually, at the time of recording in, October 2024, we have you can clone the repo. It's Zed is open source. The bulk of the code is GPL licensed, but the UI framework is Apache. And you can build the repo on Windows. For a long time, we had the same situation with Linux, and then we had a kind of team push to get it from it builds and your mileage may vary, which is kind of the status of Windows now, to like, this is official. And even then, it's really hard on Linux because it's just so diverse.
Yeah.
So before we sort of officially endorse it on Windows, I think we need a similarly like focused team push around just like tying the loose ends up. But you could experiment now. Yeah.
But at that point, like once you've got it, I could use that library and I could have a single source that would work across all these platforms.
Yeah.
Wow.
Yeah.
So why did you build GPUI?
Yeah.
Did I get that right? GPUI.
Yeah, I mean,
so this is Rust, and it's
Yeah.
GPU. What was the need for?
Yeah, I mean, I called it GPUI just because, like, I don't know, I have a penchant for like simple names, I guess, or like short, kind of to the point. Yeah, and it was
Atomic names.
yeah. But when we first started on Zed, we originally thought, oh, maybe we can like write all the core hard parts in Rust and still have the UI be an Electron. That didn't last very long because we did all this work to make the core fast, and then we'd immediately like pissed it away, parsing the JSON and diffing the React trees and everything. So finally I was just like, we can't do that. And so the idea was like, what in React, what you're doing, right, is you build the virtual DOM. Why do you build a virtual DOM? Well, because you need to be able to diff one version of the DOM against the version you want. And then once you've
changed, though.
Right. Once you've diffed it, now you can go grab the retained mode structures, the object-oriented representation of the DOM, and change that. And then the browser can recognize that you've changed that and reapply the styles and relayout and all that. And I was just like, what if we just build one tree and just feed that thing to the GPU as fast as we possibly can? Like, that's what a video game does, right? Like, I was looking at, like, whatever the latest, like, electronic computer expo demos were at the time, and just seeing these, like, crazy 3D worlds that were being rendered at ungodly frame rates.
Yeah.
Just being like, okay, surely.
Why is my code editor so slow?
Yeah.
So could the UI framework be used to create games?
Yeah, although it's mostly for, I think, like, productivity apps, I think, because it's really
Like
more
menus and
exactly
rendering and
like at the core of this UI framework is like 700 lines of shader code, roughly. And like, what does that shader code do? It draws boxes with rounded corners. It draws drop shadows. It grabs textures out of a sprite atlas of like the n different variants, subpixel rendered variants of every single glyph that's needs to be rendered on screen, and sort of like typesets them on screen as like quads, right? So it's not, I don't think it's very, the game you built wouldn't be very fun. It's very much, it's
it's
about
been built as a productivity UI kit, not a like general,
Could you build an email client on it? That was amazing.
Yeah,
yes.
right.
So are you actually rendering your own fonts?
We call out to Cortex to rasterize the font, and then we, depending on where the font is positioned by the layout system. So I'm talking on Mac. Obviously on Linux, we have our own story there, but like on Mac, we use Cortex to perform layout, which we cache, and then depending on where the layout wants the character, we'll choose a different subpixel variant of that character. If we haven't rasterized it yet, we'll call into Cortex to rasterize it and then upload it to a sprite atlas on the GPU, which is just a big texture. If you look at it, it just looks like a ransom note or whatever, right? Like with all the different like characters on there, and then we just like composite sort of little sprites onto the screen, for every single character where it needs to occur. Antonio can describe the math behind it, but we rasterize Bezier curves on the GPU. We do this cool Gaussian blur thing that we cargo occulted. Well, we understood it eventually, but we took it from this Figma blog post that Evan Williams did for how to do like a Gaussian blurred box for drop shadows. Yeah, anyway, it's all just like fairly simple. We use sign distance fields for everything, which is just basically simple mathematical formulas that describe how far a pixel is from the edge of some piece of geometry. So you could imagine some formula like imagining a rounded corner rectangle with the center here. For every pixel inside of a certain area, like, is it inside the rectangle? Is it outside the rectangle? Is it right on the edge of the rectangle? If it's right on the edge and the rectangle has a border color, then we're going to sample from the border color and blend it into the background color if it's sort of in between the border and the edge.
Yeah.
But
There's quite a bit of engineering just in the GPUI.
Yeah. But what it ultimately got us is like, my favorite demo to give is like, get high frame rate. Like I have one of the new MacBook Pros that have the ProMotion displays that kind of burst up to 120 frames. And I have always, and this is probably why I needed a faster code editor, I've always overclocked my key repeat rate so the cursor moves faster. So I have my key repeat rate overclocked, and I just hold down the binding to switch tabs in the editor, and you can read the contents of every buffer that's open in the workspace at the same time because they all just blur over each other. Because so just like
so fast.
Yeah, and that's like, I don't know, it feels really good being on this foundation and having a ton of headroom.
It makes coding feel like you're playing a game.
Exactly. Yeah, exactly. It feels really satisfying, just always never dropping a frame.
Yeah.
And I think, I don't know, it's hard for me to imagine going back ever. Even if I hadn't written it myself, it's my baby, so I wouldn't go back. But like, just going back to an environment where frames are getting dropped, even if it's only every so often that a frame gets dropped, it's annoying. It's like a microaggression against your coding flow. To have that
laggy code editors, so just constant microaggressions. This is how I feel though. When my editor is being laggy, I start cussing at it for sure.
Yeah.
So maybe it's more microaggression to me towards the. It's like, hey, leave me alone, man. I'm doing work for you, and I'm like, can you do it fucking faster?
So you're able to assume that every computer has a GPU on it?
Yeah.
Okay.
Yeah. Which is true. I mean, we don't do anything so crazy that we even need to, like, for a long time, like, there was sort of the integrated GPU versus the discrete GPU.
Mm-hmm.
Nothing we're doing goes beyond what you can just do on an integrated GPU.
Okay.
But yeah, on every frame, we redraw the entire window, just like a video game.
Mm-hmm.
It's pretty fast. It's very power efficient. Like, maybe we could do better and sort of preserve pieces of it. And, someday I think we will. But even today, we just keep it simple. How fast can we redraw the window? And the cool thing there is, like, when you're resizing it, not that that matters that much, but things like the switching tabs where it's just like, boom. And then, of course, it's not just that. It's like taking care to do things off the main thread so that, like, when we soft wrap, for example, if we go over a certain deadline, you will actually render the buffer that you open with the line overflowing off the edge. And then, like, 2 frames later, you'll see it pop in.
Huh.
And for me, it was like, I'd rather get instant responsiveness, even if it's not perfect, and then
correct it.
pop in.
Yeah.
So
performance seems like that you guys have put a lot of work in and really nailed that one. And
right.
CRDTs and concurrency and Rust have kind of made that all possible.
Right. And now they're opening, and I think the next frontier is really figuring out what does an AI-enabled coding experience look like.
Yeah. So where are you at with AI, and then what are some thoughts if you want to share on where you're going?
So yeah, we're very much still learning. I think, like everybody, the first thing that we built, which I'm really proud of, is just the inline transformation experience, where in any piece of text you can select or put your cursor, you hit Control Enter, type a natural language prompt, and we'll generate some code where your cursor is, or rewrite the selected code. And I think we have a really clean UX around that.
Nice.
That will always pull in the context in the assistant panel. So the next big piece we built was the assistant panel, which pops out, by default on the right. Yeah. It's a chat interface. I think what we've done with it that's interesting and a little different than the typical thing is we've modeled it as very much a text editor. So the idea is that the entire context that you're sending to the LLM, even though it's like structured like a conversations, because that's a useful way to interact with it. That's how these things are trained. So you see sort of the text broken into user, system, assistant, but it's not like an append-only UI. It's editable in its entirety. And when you insert new pieces into the context, like we have these slash commands, so you type like /file, you can put like the name of a file or a directory. We just insert like folded text. So you can actually inspect sort of everything going to the model. And you can take the model's output and use, fully keyboard-driven workflow and select it and mess with it and tweak it. So that was all very inspired by like being raw and on the metal. I think the next chapter is going to be how do we go beyond that and start automating away more of that. So what we're working on right now is improving. It's working in-house, but we have a little work to do to get it out to all users, where you can just do a search, which is sort of a combination of vector-based retrieval with keyword-based retrieval.
It's like querying your code base.
Exactly, yeah. So that's going to start as a slash command where you just type slash, I think it's /project, and based on all of the context around it, the LLM will be instructed to like construct the queries to do the retrieval, pull the text back and you can see the text. It's right there. It's just folded text.
Yeah.
So that's one big piece. And then these live diffs that we're building, which is sort of, you can instruct the model or allowing the model to suggest edits. So any of the code you've brought in will always have a path and some little excerpt from the code. Now, when that leads the model to suggest an edit, that'll pull up this live diff view that lets you sort of review and apply on a hunk by hunk basis this little micro pull request that the assistants opened up for you.
Yeah.
And then one more thing that we're working on is we built these I was describing those multi-buffers to you. Go ahead.
Are you moving on from AI? Because I have questions.
No.
Okay.
No, it's AI
Still in the AI realm.
Right now, when we originally built the multi-buffers, we built them to reflect the output of the Rust compiler. And so the idea is for every error, there's like an excerpt of the code. And that led us to make a decision that I consider suboptimal, which is to sometimes represent the same text more than once in a multi-buffer, which is kind of confusing. And it really falls down with this UX that we're hopefully by the end of the year going to have in place, where we show a multi-buffer for every error you have in the code base. I always thought that was cool, and it's amazing for certain kinds of refactorings, right? Because you can a lot of times do like a multi-cursor edit that will like add some default parameter and just be one edit across your entire code base.
Yeah.
But what I'm really excited to do is highlight that entire thing, hit Control Enter, and already in a multi-buffer, it's just the problem is that see the same text twice, so it kind of breaks when this happens. But when you have a selection that crosses excerpt boundaries and then you hit Control Enter, will pop up a parallel transformation for each little excerpt. And so the idea is like, you want to add a parameter, maybe there's some context that's relevant in each of the spots where this function's getting called that would be useful in this LLM, just making a fairly brain dead decision about what to pass right there. Highlight it all, Control Enter, and in parallel, just have the LLM fix every single error in one coherent UI.
That's awesome.
So there's that, and then everybody wants the Copilot style autocomplete, which we support Copilot and Supermaven, but they want
there is a Copilot plugin, but they want the like multi-line completion.
They want like the cursor style like tab to go to the next thing, multi-line, and they want it to be bundled as part of like the first class AI features. So that's another thing. This is all like in flight, and hopefully, depending on when, some of it will be out in November.
Nice.
Some of it won't be out until the end of the year.
Yeah. So
now
when I met you at LambdaConf, I was just getting into the world of AI code assistant stuff, and I wasn't really convinced yet. And you were like, dude, like, look at all of the things that I'm asking the AI all day long and how useful this thing is for learning and exploring and helping. And you were definitely like helped me kind of see like, oh, I need to like really put some energy into changing my muscle memory around how I learn and how I use these tools. And so I think based on that experience with you is that you're using these tools all the time,
right?
The AI code assistants, and so I think what a great way to drive what you do in your product, because you are really a power user on the like end of the spectrum for how you're using the tools, where most people are still kind of working their way, like me, kind of working their way into it.
But it's been a challenge for us too. I mean, it creates kind of a weird trap, right? Because like we all have habits, and none of our habits as these very experienced developers involve generating code with AI, because it's very new, right? That's a very new thing to exist. Younger kids that are coming up right now and just learning to code, I mean, they're swimming in this constantly because like for them, I cannot imagine, even when I was learning Rust, having an LLM that would even bullshit me through a solution to some of these problems.
I did. I spent a couple of months learning Rust, and the first was mostly like watching videos, and then the second month was the AI became available to do that. And it dramatically improved my learning. By the end of the second month, I go, I think I have a grasp of all the keywords now.
Right.
And because I could say, here's what I'm interested in. Write me an example. I could study that.
Right.
And that's, rather than, oh, the next thing in the book is what we decided was the next thing for you to learn. And
Right.
maybe that's not right for me at that moment.
Right.
It was,
And
so,
even if it's not perfect, it doesn't matter if you're learning. It's still
it's even
manna
better
from heaven.
because I have to compile the code and I have to understand. It was almost like having the little flaws was helpful because it's
interesting.
like, here's your exercise. Make sure this is right. Make sure you understand it and fool around with it. But it would give me the starting point when I would ask about something, and that was just.
And I don't like to feel dumb asking questions, and so the LLM
Doesn't judge you.
Yeah, it doesn't judge
no
me.
judgment.
No judgment.
Right.
Yeah,
Yeah.
I think one of the hardest things is to teach myself to not try and figure it out all in my head. Go, oh, that's right. I should ask the AI, and then it
Right.
helps me leapfrog forward, and I don't run out of energy. I don't run out of mental energy trying to struggle through it myself, and so I feel like I really move forward a lot faster.
But I think I share all that experience. At the same time, I think, and there are people on my team that don't use it as much. And the reality is that like a lot of it's our own fault, right? It's in our editor, our search needs to be improved. And so if you're solving a problem where you need to be gathering context from disparate areas of the code base, there are times when that's annoying right now in Zed, and we're working on fixing it. But like, and so, or it's just like, sometimes a lot of the, like, I feel like AI's sweet spot is like just cranking out a slightly different version of something that's been done millions of times. When you're solving like a really novel problem, I find that it isn't always as useful. The ratio of kind of boilerplate to novelty, a lot of times in our code base, trends toward novelty. It's just like there's not that many code editors in the world to crib these algorithms from and stuff. And so like I'm actively having to make sure that we don't fall victim to like the innovator's dilemma or whatever, like because we're using a lower resource language, Rust, it's just not as much training data out of there. Yeah. We're using our own tools, which aren't designed with the assumption of all these habits existing because it's a brand new situation, right? Yeah. We're solving maybe more novel problems than are typical, like making sure that we don't, fall into our own trap of blindness, I guess, and underuse the potential of this tech.
Yeah.
But I think,
we just continue to discover new ways that we can use it, and so like it sounded like one of the things you're talking about is kind of like fixing errors across multiple files all at once, and like that's something we've never had before, and it's something that the AI can do pretty well. And so I think we're still at the early days of discovering how AI impacts us as developers and how the tools expose those capabilities to us. So
yeah, it's a real wonderful opportunity though. I'm enjoying it a lot. Yeah. I did not know that I've been obsessed with code editors for a long time, but even when we started Zed in 2021 and got that initial investment and started off, I had no idea what was coming for us. Yeah. And now we sort of find ourselves with this awesome code base, great team, and this whole new way of doing things to play with. The challenge is, of course, we still have a little bit more to go to bring up the table stakes kind of 1.0 features. Like we're working on SSH remoting right now. That's getting really close. I think we'll have that out next month. Committing from the editor, like Git committing. People really want a debugger. There's a community contributed one that needs a little love. So I think we'll be spending sort of a decent chunk of resources building out the rest of that. Like, okay, this is what you just need in the basic editor. And then a lot of our resources like playing. But the cool thing is as that comes in, as that full picture starts to come into view of the 1.0 feature set and more of these AI features coming along, we're in a really unique position of basically having one pretty small team, one very new, very well taken care of code base. We understand the entire code base. We're in a really good position, I feel like, it's like a bar fight has broken out and we know jujitsu in this particular moment. So I'm feeling lucky right now.
Are you in a situation where you're starting to hire people now?
We are, we are very interested in I think we're ready to start ramping our hiring more aggressively. We've got a core team in place. We do a lot of pair programming, collaboration being one of our core things. It's not like you pair all day, every day, but like people that are excited to kind of pair a couple days a week. It's a great way to just ramp people into the culture. We're distributed, so we can employ you anywhere.
Nice.
I guess we're very particularly interested in like North American and European time zones. So, or
It's
South
like
America.
if you're going to do pairing, then being in similar time zones is helpful.
Exactly. Yeah. Danilo joined from Brazil. But...
Oh, okay. You said you were about to say South American as well.
Yeah, exactly. Just like north, south. Yeah, exactly. There's good time zone
alignment. Yeah.
Yeah. Yeah. So people that are, and I don't know, it's tough because Rust is sort of selects for a certain style of programmer, and yet we're very much a product, right? Like, I think there's a lot of Rust work that's much more back end. You never really see users or like back end or embedded.
Yeah.
We're kind of like, I don't know, we need sort of the same personality of builder, the kind of builder that would love to roll up their sleeves and like a crank out Python or crank out React. Product engineering, building features, caring about what users care about, but then doing it in Rust.
Yeah.
So,
well, and also you said before you were elegance was important to you. I created a T-shirt years ago for the Python conference, and it's elegance begets simplicity. So we're on the same page there.
Yeah.
So
but hard to find the overlap of people who can do elegance, create elegant things, and know Rust. So I think what you're saying.
Right. And also, but more than anything, it's like, and then there's the kind of Rust developer that they're so obsessed with theory that they never ship anything, So we need, I don't know. And I'm willing to sort of
startup. You got to move quick. And
we got to ship. We got to write quality code. I'd almost rather you ship and then be good at taking feedback to improve the code if it isn't, up to our quality standards, than the opposite of like sort of be paralyzed with fear about not making something good. Mm-hmm. So just like, people that want to ship would be fabulous to get involved.
Ship and shred.
Ship and shred, yeah.
In the writing world, there's a maxim that says, writing is rewriting.
Exactly.
And that's what you're talking about. And you got to write first. I've seen people who are so paralyzed they can't get a sentence out. And it's like, well, you got to get to the point where you go, we'll make the sentence, and then we can just keep making it better and better and better.
Right. But anybody passionate about building good product, I think at this point is potentially a good fit. Even if you're not, I think I want you to have like read a book on Rust and have like started playing with it.
And be able to ask the LLM good questions about Rust.
Exactly. But more than anything, is just someone that wants to roll up their sleeves and work hard and help us make the best code editor ever.
That's awesome. Well, on that note, thank you so much, Nathan. Super fun to have you here in Crested Butte. And,
really interesting.
Yeah, really interesting stuff. And hope it all goes well, because it's. I'm all for better tools for developers. I think it's really important.
Oh yeah.
Thank you. Thank you for inviting me in your space. And
absolutely.
Yeah, this is the first podcast I've done in person for Zed. So
awesome.
Excellent.
All right. Well, thanks.
Thanks.
Nathan.